In this video, we're going to prove three important lemmas about inequalities involving reciprocals. All three of these lemmas state facts that you should know, and they are important facts that are very useful in a number of different ways throughout this particular course. The first lemma says that if x is bigger than 0, its reciprocal is also bigger than 0. Well, here's how we're going to go about proving this particular fact. I'm going to start by writing down what I know. We know that 0 is less than 1, and we know that 0 is equal to 0 times 1 over x, and we know that 1 is equal to x times 1 over x. We also know from the hypothesis up here that x itself is bigger than 0. So what I want to do is I actually want to start with the inequality. X is less than, rather 0 is less than x, which is just a way of rewriting that, and multiply this inequality by 1 over x, and we get 0 times 1 over x, which is 0, is known to be less than 1, which is x times 1 over x. And what I want to do is I want to think about what this actually means. So we have 0 is less than x, and we have 0 times 1 over x is less than x times 1 over x. Now, that is enough to say that 1 over x must be bigger than 0, because if 1 over x were less than 0, then 0 times 1 over x would have to be bigger than x times 1 over x. And this didn't happen. This would be 0 is bigger than 1, which is nonsense. And because this can't happen, we must have 1 over x is indeed positive. So that ends the proof of the first lemma. The second lemma states this. If we have 0 is less than x and x is less than y, then the reciprocal of x is bigger than the reciprocal of y. In other words, taking reciprocals changes the order of the inequality if everything in sight is positive. Now, we're going to be able to use lemma 1 in the proof of lemma 2. So here's the proof of lemma 2. We're going to start off with the inequality x is less than y. And we know from lemma 1 that 1 over x is positive because x itself is positive. So x times 1 over x is less than 1 over x times y. Well, let's see, that says 1 is less than 1 over x times y. Now what I'm going to do is I'm going to recall that because y is bigger than 0, that implies that 1 over y is also bigger than 0 by lemma 1. And so we can say that 1 times 1 over y is going to be less than 1 over x times y times 1 over y. But we can clean up our arithmetic here. These y's basically cancel out. They multiply together to form a 1. And 1 times 1 over y, of course, is just 1 over y. So this inequality says that 1 over y is less than 1 over x. And we already know this, so we actually do have 0 is less than 1 over y is less than 1 over x, which can be rewritten as 1 over x is bigger than 1 over y is bigger than 0. So taking reciprocals of positive numbers changes the order. In other words, if 0 is less than x is less than y, that does indeed imply that 1 over x is bigger than 1 over y, which will stay bigger than 0. So that ends the proof of our second lemma. The third lemma is really just a special case of the second lemma. If x is bigger than 1, its reciprocal is going to be between 0 and 1, and if x is between 0 and 1, its reciprocal is going to be bigger than 1. So the proof of this particular lemma. If x is bigger than 1, and 1 of course is known to be bigger than 0, then lemma 2 says that 1 over x is less than 1 over 1. And 1 over 1, of course, is 1. So that says 0 is less than 1 over x is less than 1. That particular inequality there is technically by our first lemma. On the other hand, if we look at the second part of this particular lemma, if 0 is less than x is less than 1, then lemma 2 says that 1 over x is bigger than 1 over 1, which of course is bigger than 0. But 1 over 1 again is just 1. So we have 1 over x is indeed bigger than 1. And that completes the proof of this third lemma. These three lemmas can be incorporated in a number of ways throughout the semester. Anytime you've got inequalities and you need to take reciprocals, you can use lemmas 1, 2, and 3. It is worth mentioning that there are corresponding formulas for the reciprocals for negative numbers. I will let you explore what they should say and prove them for yourself.